Hi, you're welcome to this coding challenge session with me. And in this session, we will be looking at a very interesting challenge known as two-sum. Two-sum is a question or a coding challenge problem that I have sourced from LeetCode and will be solving using JavaScript. In this coding challenge session, we will walk through the question, the solution of this challenge, and also have the opportunity to learn the algorithm used, the logic employed, and some new methods probably in this session. So let's get right to the question. Given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to targets. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So I will draw up my whiteboard, and then we can look through, or better still, interpret this question in a more graphical way. So back to the question, it says, given an array of integers and an integer target, that defines our input. So we have our inputs as an array and an integer. Okay, now going forward with the question, it says we are returning the indices. Indices is the plural version of index. So we are returning indices of the two numbers that such that they add up to targets. So let's take out the indices. We are returning blah 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 of two numbers. Let's take out the such that let's take out the they add up to target. So it means we are returning the indexes or indices of the two numbers when added will be equal to target. So right there, I see that the sentence is quite tricky, but because I'm here to give a wholesome solution to in this session, better put, I would like that you see it this way. At first, we are saying we are being told to return indices. So we are expecting indices. Okay. We are returning indices. Yes. Okay. Pardon me on that one. Okay, we are returning indices and the indices of two numbers such that they add up to target, right? So let's go deeper into the question. We have an example here that says the inputs, like we said, nums equals the array and target equals 9. Target is the sum of two separate numbers or integers within this array. And we expected to find those two numbers and return their indices. Right here it says you can return the answer in any order. That means, let's say the first one is for 9 here, we have 7 plus 2. That gives us 9. That tells us that these are the two numbers and their indices are 0 and 1. And in any order means it could be 1 and 0. If you're pretty new to this, which most times my videos are made for, that is beginners, you might wonder, okay, she went through this, she skipped this, she came here, and then she's going back, right? If you pause this video and rewind, you would realize that I read everything. I took out my inputs, or deduced my inputs rather, my expected output format, right? And I'm going through the example. So having looked at the example and seeing what the expected output should be for example 1 and same with example 2, I can simply say that we can look into a logic that should work here. Yeah. So let's take, for example, 3, 2, 4. So if we have an array 3, 2, 4, and the target is 6. Yeah. What logic can be employed in getting the two numbers that, when summed up, would add or be equals target? While looking at the screen, I am sure you have guessed or stuffed it out that 4 and 2 are the numbers eventually. But because we do not have code, right? Most of the time, the essence of doing this is to develop algorithmic thinking, which in turn helps us to deduce solutions to problems and implement effective solutions in the most efficient way. Great. So assuming that this is a problem that has been thrown to you, and the stakeholder or the client has an expected output, and have been able to come up with the expected input, it is our job to be able to implement a logic that will take the inputs and give out the expected outputs. And that is what we are doing here. So from what I see here, starting with JavaScript, I will say the first step I would do, or one of the things we would do, is to look through this array. So we look through this array and then check or check for the possible sums of any two numbers within the array. Now, while looking at this, I would say that if I should pick out 3, for example, that is index 0, index 1, and index 2, I am going to do something like this. 6, that is the target, minus 3, which gives me 3, right? Now, I will pause here to explain the reason why I thought in that direction. It's simple arithmetic and simple arithmetic here. If 3 plus another number, right? If the number on my first index is meant to be added to another number to equals the target, it therefore means that if I should subtract my first index or the index that I'm currently at while looking from the target, I can be able to know the next number that I need to add to that to give me my target, right? Now, the next thing is, if 6 minus 3 is equals 3, then I will decide here to check if the remainder can be found within this array. Just to note, I am meant to return indexes of 2 numbers. So if I should check through this array and what I have is the 3 that I'm working with, then it means this is not a valid second number because it does not exist in the array. Although this result plus this 3, right, in the first position would give me 6, but the remainder, however, does not exist here. Like I said, I need another number, a second number. That means I am not expected to repeat the same number that I am working with. So that will lead me to go into position 1 or index 1, where we have 2 here. And I can go the same route, 6 minus 2, and that will give me 4. The same thing applies. Now I am at position 1. I would want to check if the remainder, after subtracting the number 2 from the target, right? I would want to check if the output or the remainder exists within the array. And currently, as we see it on screen, it does. So it means I have found the 2 numbers, 2 and 4, 2 and 4. And the indexes are 1 and 2. 1 and 2, these ones. Right. So those are the indices. Okay, so how do we get this interpreted or translated all represented in code. Now it looks easy right now, but I do not want you to get off this video because there is a challenge that I am currently foreseeing. Now the challenge I see here is that in a case where we need to find out if a number, a remainder exists in an array, and we have that same number, an identical number, or we are working, okay, better put, in the case where we're working with a certain number, and the remainder happens to be identical with the number we're working with, and not double represented in the array, how do we get to, how can we, search through that array in a way that that number that we're working with would be ignored? The usual way to do that, to search through an array to find, in order to find a particular number, is to say something like this, or a particular item is to say something like this: nums.index and nums.includes, right? Using the .includes method. That's one of the methods that can be used. But if we say that this array includes 3, it's going to give me, yes, it's going to give me true, because indeed 3 exists within this array. But we're not looking for, we're not meant to make use of a certain number twice. If we have 3 after 4, then yes, that works well. But it exists once, right? We have just one instance of 3, and it is the target. It is the target at that point, the target we're working with, and it cannot be a representative of the remainder as well. So what do we do? So what comes to mind, the solution that comes to mind, if you have other solutions, you can leave that in the comment section. But what comes to mind is to always take out the target number, not this target anyways, the target. So it means when I'm working, I'm checking or looking out for the second digit with a certain specific digit, right? I should take it out completely. That is the logic I would make use of in solving this question, right? If you have any other method, like I said, please feel free to share. So let's get right into solving it on screen, on code. Yeah. So like I said, we're going to make use of a for loop. For let I equals 0, I less than nums.length minus 1, I plus plus. Okay, so we have fulfilled that for loop using a for loop. Okay, so in looping through this, we want to pick out a certain number and then do our the subtraction and then check through. So the next step will be to get the target, right? Which will be this. Let first equals, I'm just going to call it first, or better still say first num equals nums dot shift. Okay, nums dot shift. So we get the target and then we can do the subtraction. Get possible second num. We can achieve that by subtracting, and we call this possible num. And we will have target minus first num. First num. Okay, so I'll be doing something here to show us how far or what we have gotten so far. Console.log possible num. So we would have more like possible numbers, like the result of subtracting any of all of the digits individually on the array from the target. Right, that's what I'm expecting to get. First, I got my first. I'm shifting from the front, right? From the front, I'm shifting from the front 3, right? I'm shifting it. That means I'm deleting it. It means I'm deleting it from the array. I'm deleting it completely from the array. And like I said, I'm doing that for a reason. For a case like this case that we had here. All right. So I want you to be carried along. And as a result of that intention, I'll be consolidating what the possible norm is, which is the result of subtracting each of the numbers from target. So we're having a for loop here. So it's going to look through each of the items in the array and then just carry out the subtraction and console log the result. So right here on standouts, this is where the console logged values are being displayed. This is the array we're working with. And right here, I have 7 and 2 instead of, like, it went through, the for loop went through twice instead of all 4 times. I'm going to explain the reason why I did that, because we're supposed to expect 7 to minus something and minus, but what we get here are 2 numbers, or what we have here, 2 numbers. And the reason is because the for loop went just twice. And it is because we are deleting. When we delete 2, right, the length of the array shrinks to 3. When we delete the other one, the length of the array shrinks to nothing, to 1 or something, like, yeah, like it's exhausted already, right? When we take out 2, the length of the array shrinks, right, to 3. Again, it shrinks to 2, right? And this is 2. Okay, I don't want to go deeply into graphically representing this, but this is 0, 1, index 0, 1, 2, 3. So when I shift the first one off, this becomes 0, 1, 2. When I shift the second one off, this becomes 0, 1, right? Now, on shifting this off, the index number, the I or index at that point, remember they follow the I here becomes, it increases, and it's already at 2. So once I will no longer be lesser than what we have left. It's going to be like I is greater than, because I is 2 and is greater than, right? It's not lesser than 2. As I've put it here, it's not lesser than 2. So you might not really grab it as I've just explained, but now we've run into an error and I want us to fix it together. If I should come off, with all good, perfect answers, then we are not learning effectively. We might learn the answer, learn the solution, but in running into errors like this and tackling it together, we get better at problem solving. All right, so what do we do in this case? It means not all the numbers can be treated. Once I becomes 2 and the length is 2, the for loop will stop, because we are truncating the for loop when I is less, as long as I is less than the length, right? As long as it's less than the length, then the for loop continues. So the moment is no longer less than the length, then it stops. So at the point when we have gone through the for loop twice, that is, I has become 2, and the length now, because we have deleted some items from the array, is now 2. It means I is no longer lesser than this, and the for loop will no longer continue. I think, yeah, I feel like I've explained it better. So I was trying to solve a problem by using shift, by deleting, and obviously ran into another. But because at this point, all I want to do is show you how, right, to show you that this is working, that we are iterating correctly. I would take out the shift and replace it later. So you see that right now we're going to have 4 different values. Okay, we have 3. It's meant to be 4 when there's a -1 there. So when there's a -1 after the length, it means I should include an equals, but I don't want the equal. So I'm going to say I less than non the length. So that gives us our complete solution in terms of the expected out, what I wanted, the expected console log output there. So I'm console logging the result of subtracting each of the array items from the target. So we have 7, 2, -2, and 6. So that tells us that yes, we are getting our possible sum, possible numbers. Pardon me on that. We're getting our possible number, and we would want to go the next step to check if the possible number exists within that array. So let's go to that. Let's get to that point. So if nums dot includes possible num, right? Then we want to console log yes. And I want to stop from here the for loop by just saying return. This is not the final return. I just want us to see at what point that we will have a yes. The moment we get a yes, the for loop will stop, and we're not going to see the rest possible nums after that. So I'm going to quickly run. Oh, it's meant to be a string. So that was the wrong variable type there. So after 7, it says yeah. So the possible num there is 7, and 7 is within the target, and it says yeah. Interesting. In other words, it subtracted 2 from 9, which is 7. That is the possible number, and then it checked through the array and realized that yes, 7 exists. So rather than console logging the possible num, how about we just console log the index of the possible num? So that would be nums dot index of possible num. Okay, so we I don't mean there. I had this at the wrong spot. Okay, so instead of yes, instead of having yes, we should have the index of the possible num. The index of the possible num should be 1. Remember, the possible num is 7. The index should be 1. That's it. So what are we meant to return? What are we meant to return? We are meant to return indexes or indices, right? And from what we see here, it's meant to be an array. So I just return the index. So let's hold this in a variable. Let second index equals this. So I'm going to have my second index there and my first index as I. Remember, I is going from 0, that is the first to the last. It's going from the first to the last. So it goes sequentially, and at the very spot that I is the very spot we are at on the array. So I is the representation of the index of the current number that we are working with. So if I should hit run, now we have one case passed. Okay, let's take a look at what we have on the one case passed. We have 3, 2, 4, and the target is 6. The expected outcome should be 1 and 2. Oh, okay. I'm looking at the wrong case here. So this is the exact case we're working with, 7 and 1, 0 and 1, exactly. Now we have 2 other cases failing, and we're going to take a look at the reason why they're failing, and I can guarantee it has to do with the first problem and the second problem that we encountered. So now we are going to be solving those problems. So in order to solve this, let's take a look at the second case that we have here. So right here, we expected to have index 1 and 2, but what we have as our output index 0 and 0. Okay, it's meant to be 1 and 2, but we have index 0 and 0. So that's quite funny, but let's take a look at our solution then. So we can start with the console log 3, right? And 3 minus 6 is 3. And remember, we are also conjugating the index of the possible number, and it shows here as 0. So the index of the or the number, the item at index 0 is 3. So it means we are targeting 3. The remainder is 3. And when we check if 3 is included, it says yes by repetitively considering this same target 3. That's wrong. It's meant to be 2 and 4. If we had another 3, then it could have been valid. But the index of method, most time, not most times anyways, but is expected to return the index of the first occurrence of that particular item, right? So how do we solve this? This brings us back to shift. But while we shifted, remember, we experienced or encountered an error where the more we shifted, the more our length, the value of the length of the array reduces to the point where the index and the length becomes the same. And what the repercussion, if you remember clearly, was that some other values were not treated. The values beyond the index that met with the length of the array were not treated. So it goes mid, it's like it appears like we are deleting some items from the left side. And the more we do that, the size of the array shrinks, and it gets to the point where it's mid-level, where we are at a certain position based on our for loop, right? We iterated a certain number of times that it's equal to our current length, that is the length of our array, right? And that is not that's not good because it stops the for loop prematurely, thereby not accommodating the rest of the numbers that needs to be checked as well. So that tells me that shift is not a good way. Well, the logic of deleting seems appealing to me. So why not pop instead of shift? That is delete from behind. Let's delete from behind. So let's start checking from behind and deleting from behind rather than deleting from the front. Now, this is why I'm saying so. If we are popping from behind, of course, the length of the array would reduce, right? But when it reduces, it's not going to affect indexes from 0 to 2. Because if we iterate backwards from the right to the left, and we check from the right, and then we delete, and it keeps shrinking, there's one thing we are sure of. The array, the for loop will only come to a halt when the length, right, is 0. That is when the length is the length, because the first index we're going to start with is the last index here, for a for loop going from behind. Okay, so to be more detailed, let's say I 1, 2, 3 is equals 3. That's what it means. We're starting from that. And every time the array, the for loop loops, it's going to go 3, 2, sorry, it's going to actually go 2, 3, 1, 0. Pardon me. It's meant to go 2, 1, 0. Yeah. So it goes like that. Now, when it goes 2, 1, 0, every time you pop out the last value and it shrinks. So let's say I goes from equals to 3. So I, that is the length. When the length is 3, the largest index is 2. When the length is 2, the largest index is 1. So that's the reason why we have it like that, because we start from 0, 1, 2, whereas the length is 1, 2, 3. So if we go this way, we have popped out 4, the length will be 2. And yet I at that point is not equals 3. So we're going to see this in action. When we see the action, is going to come a lot together. But from what I see, if we iterate from the right to the left, we'll be able to pop out effectively without having to run into that error we run into when using shift, because the for loop would go to an end only, get an end only when the index is at 0. Whereas if you are shifting from the left, right, the index would only, the for loop will only stop or come to an end when the value of I is now equals or greater than total length. And remember, the total length will keep reducing, the value of I will keep increasing. So at some point, it will get to a mid-level and some values will not be covered. But when we are going from right to left, the length will keep reducing, the I will keep reducing. It is reducing simultaneously by 1 each until it gets to 0. So we're not going to lose out on anything, because eventually we will get to 0 and we'll be treating all the numbers adequately, correctly, inclusively till it gets to 0. I hope that does a bit of explanation there. So I'm going to, at this point, change this to nums.pop. Okay. And then look backwards, where I will be equals nums.length minus 1. Now we will keep reducing I until I equals 0. So this would work because we pop from behind is fine, that we pop from the right is fine. The I as well is starting from the right. Both of them are starting from the right. We're taking out, we're deleting items from the array from the right. We're starting from the right, and the I, the index right from the right, keeps reducing by 1 on each loop till it gets to 0. And as well, we keep popping by 1 each item until it gets to the last item, which is 0. So it's going together. In that manner, we are able to first ensure that all the items possible are observed, used within the for loop, are covered within the for loop. And then secondly, which is the most important one, we will not have to this error of recounting a previous or current instance of an item again, especially when that item, right, is the same number with the remainder. So if we have treated, we are working with 7, for example, or we have worked with 7, and the remainder after subtracting 7 from the target is 7, when we look through the array to find if 7 exists as an item within the array, right, it shouldn't be valid, it shouldn't be true, it shouldn't be there anymore, because we delete the 7 and then we subtract the 7 from the target, and then we'll check what the remainder is and compare if if the remainder exists within the array. If it does, it should be that it is another value, not the same value that has been checked before or currently being checked. So that is what the pop helps us do. Take it out of the array, so we don't have that error of multiple representation of that same number, whereas we need a second different number, not that same number. I hope I did a great job with explaining that. Anyways, so what we have now is this. We're going from the back, we're popping, and the return value would be affected because at this point, the second index, the first index I would be, let's see. The index of this possible one will be the first one. That is, the second index will be the first one. Remember, the second index would most likely be any of the numbers from the left side, because we're going from the right to left. And the second index will most likely, now this is another challenge. How do we get the second index when we have popped it out? We can't even check what is the index of that particular item anymore. So let's do a little bit of logic here. Let's implement a little bit of logic. It means that we can say the second index will be nums dot length plus 1. Plus 1. Remember, we have popped out the last digit, the last item, and the length has reduced. So for example, if we had 3, this has been popped off or popped out. Now we just have 3 and 2. So if I want to find out the index of this 4, right, that is the index of the just popped out number. It is only, we're looking at the index of the just popped out number because that is the number we are checking with currently that has given us the second number that we need, right? Great. So it just means we get the length of the current array plus 1 will give us the index of this. So the index of this would be the length of the array. So instead of saying because the length of the array here is 2 and the index here is 2, 0, 1, 2. So we just say nums.length, except you're saying nums.length minus 1 and then you go add plus 1 again. Right? So it's still the same thing, minus 1 plus 1, still the same thing. So we just say nums.length. Okay, that is the last index plus 1. This is index 0, 1. This is length 1, 2. This is index 0, 1, 2. Right, so let's run. Now, this is a long solution, but it's actually a short solution, other than we are trying to give a thorough answer or a solution to it. So currently the test cases are failing, and I would like to find out the reason why. We tweak something. So let's see. I equals nums.length minus 1, correct? I equals 0. It stops there and it keeps decrementing. And then we have nums.pop, which is great. Let's see what we have as our output. Undefined. Why? Everything there is undefined. Okay, so let's see. We popped it out. Target minus first num. Okay. And then I'll just change the names because now we are going from behind. It's meant to be second num. Second num. Then we have nums dot includes possible num great. Okay. So second num, also possible num. If nums dot include possible num exist, then we consider the index of possible num and then let the second index. Okay. So I'm going to call it first index. All right. And then we call it first index. Then nums dot length as the. Okay. So the issue there is not even all of that. The length was spelled incorrectly. I had used HT instead of TH. That was the only error there. However, I have used the opportunity to rename the variables accordingly. So why do we still get undefined? Let's check if we have any typo error or spelling error. Okay, so it's meant to be when I is greater than equal to 0, it stops, not when I is equal to 0. So it means that I'm looking at everything above 0, not when I say just I equals 0, it means I'm looking at everything both below 0 and above 0, which is not definite. So that was the reason for the error. So the errors were basically the typo error and then the greater than omission here. Aside that, we have but before then, I just want to go through the solution again. So we have a for loop that loops through the nums, and then that is the array. And the reason why we are looping is to pick or integrate the array to work with each of the items per time to determine the number, the second number that can be added to it or summed up with it to give the target, to produce the target, to equals the target, which we have passed in as well here. So that's what the for loop does. And each time it loops, we're looking from behind, right? That is I is the last index number, the last index number from the right. This loop is meant to continue, right, until I is equals to 0. And looking above 0, beyond 0, it's going to continue as long as I is greater than 0, but stops when I is equals to 0. And then this is the decremental that helps to decrement I, so that it goes from this point to this point. So we are doing this, and In doing that, we're going to be popping as well. So at every time we are decrementing, we are also popping the last value, and we are popping it like we are deleting it completely from the array, so that when we are checking through the array to see if the possible number, which is the result of subtracting this number, that is the second number, the one that we are deleting from the target, right? If this possible number, which we get from this by doing subtraction, right, exists within the array. If it exists within the array, then we will get the index and also, right, return the index of the number which we just got, which is the length of the current length of the array, and then the index of the number we just got, that is it, and then the index of the possible number is simply gotten from getting the index of the number using the index of method. That sums it well. So I believe I have summarized it adequately, correctly, and it is well understood. So this is a very simple or easy. It's graded easy anyways. Yeah, it's an easy question. It's quite tricky, but I have been able to not just walk through the solution, but do it organically by tackling possible problems that we encountered, enabling us to build a stronger algorithmic thinking or thought pattern, as you may call it. All right, so I'll see you in the next session where we walk through another challenge together, solving it, solving other, breaking through other blockers as we go through the solution, and then learning more for ourselves. See you again.